Good morning to all. My name is Dr. N. Babu, Associate Professor, Department of EEE JJ College of Engineering and Technology, Tiruchirappalli. I would like to present microprocessor and microcontroller. In microprocessor and microcontroller, first of all, I will discuss with microprocessor only. Initially, what is processor? How many units available in the microprocessor means important three part. Any processor consists of important three part. One is called input unit, another one is called output unit, another one is called central processing unit. See, input unit, output unit, central CPU or otherwise central processing unit. It is the brain of the system. It's a processor. The CPU again consists of three parts. One is called ALU, another one is called memory unit, another one is called control unit. First of all, ALU. What is ALU? Arithmetic and logical unit. It performs all the arithmetical and logical operations. The arithmetical operations are addition, subtraction, multiplication, division, increment and decrement. Logical operations are AND, OR, XOR, rotate, compare. Memory unit. Memory is a storage device. It is used to store either instruction or memory address. Memory may be classified into various types. In our processor part of memory may be classified into important two types. One is called RAM memory, another one is called ROM memory. RAM is a random access memory. It can read and write operation. We will do. Otherwise called is a data memory. ROM is a read only memory. It can read only access with the read. Otherwise called it is a program memory. It is used to store main program in the processor side. Then third one is important unit is control unit. This control unit, it is used to generate all the control signals and status signal. This unit is used to synchronize the operation between internal and external operation, either processor with memory or otherwise processor with IO or peripheral or external devices. This is the basic block for microprocessor. Then what is microprocessor? What is the function of microprocessor? Microprocessor is a programmable clock-driven register-based electronic device that reads the instruction from storage device. The storage device that is called memory. Memory is one of the storage device. Takes the data from the input. It's a one part of the unit that is the input. And processing the data, that is a CPU or processor. It is processing the data according to those instructions. What instruction we already stored, that instruction, based on this instruction only processing the data. Finally, after complete the processing, then provide the result as a output. This is a basic function for microprocessor. Then memory we will discuss that second diagram. This one is a simplified architecture for 8085 microprocessor. Microprocessor has various generations are there. 4-bit microprocessor, 8-bit microprocessor, 16-bit microprocessor, 32-bit microprocessor. Now I will discuss only the 8-bit microprocessor. The name of the microprocessor is 8085 microprocessor. It consists of various blocks. Various blocks are there. For example, accumulator, temporary register, flag register, ALU, instruction register, instruction decoder, general purpose register, stack pointer, program counter, incrementer, decrementer, address buffer, address data buffer, control unit, interrupt control unit, serial control unit. So many blocks are there. We will discuss one by one. First of all, accumulator. I already told 8085 microprocessor is a 8-bit processor. It can access, what is the meaning of 8-bit processor? The database width is 8-bit. It can access only 8-bit data. So it is called 8-bit processor. The accumulator is one of the register. What is register? It is used to store the data. Register is made up of flip-flop. How to store? It's a binary data, either zeros and ones. Accumulator is one of the 8-bit register. It can store 8-bit data. Okay. What is the function of accumulator? The function of the accumulator is during the execution of the program, either add instruction or sub instruction or mul or divide, any one instruction. During the execution of the program, one part of the data. Suppose if you want to add two 8-bit data, means one part of the 8-bit data is placed in the accumulator. That is the one function of the accumulator. Another one function is after complete the ALU operation, the result is placed in the accumulator. These are all the important points in the accumulator. Is a very important register, accumulator. Next one, temporary register. During the execution of the program, some of the instructions, during the execution of the sum of the instruction, it is used to hold data temporarily. So it is called temporary register. It is also one 8-bit register. ALU, already I explained. Arithmetical and logical unit, it performs all the arithmetical and logical operation. The arithmetical operations are addition, subtraction, multiplication, division, increment and decrement. The logical operations are AND, OR, XOR, rotate, complement. These are all the logical operations. Then flag register. Another next 8-bit register is flag register. What is a flag register? It is used to identify the status condition after complete the execution of the program. What is the status of accumulator? What is the status of register? After complete the ALU operation, whether if you want to add two numbers, whether carry is present or not. If carry is present, what is the status? That is called the identify the status condition of the register by using the flag register. There's 8-bit register, only 5 registers only identified. Name is sign flag, zero flag, auxiliary carry flag, parity flag, and final one is a carry flag. If you are adding two numbers, suppose two options are there. One is whether carry is present or not, or carry is not present, based on our input data. Whatever the data, we choose it. Based on the data, the carry, whether the carry after addition of the two 8-bit numbers, the carry is present or not. If carry is present, the particular bit is set. That is, carry flag is set. Otherwise, the carry flag is reset. The same thing happened in the parity. We have two parity. One is even parity, another one is add parity. Then auxiliary carry. Auxiliary carry means, that also explained, diagram. Here I already explained. Auxiliary carry. This is a carry flag diagram. Auxiliary carry, this is used for only binary coded BCD operations. Then next one, zero flag. After complete the logical operation, for example, if you logically XOR with the two numbers, finally the result is 0, the particular 0 flag is set. Otherwise it is reset. Then sign. Final D 7th bit. That's the 8th bit is D sign flag. Sign flag means it has two signs. One is positive, otherwise negative. After complete the ALU operation, the result is positive or negative. Based on the result, the particular flag is set, whether reset or set. Set means 1, reset means 0. This is a flag register. Next, instruction register and decoder. What is the instruction? Instruction is a command. It's given to the processor. Based on the instruction only, the processor processing the data. The data getting from input. Already initially I explained clearly. That is the instruction, is a command, is a mnemonics. Add means addition of two 8-bit numbers. Sub means subtract from one number to one 8-bit number. One 8-bit number to another one 8-bit number. Increment. The register value is incremented by 1. These are all the instruction given to the processor. Processor, based on the instruction only, the processor processing the data. So the instruction is register is used to hold the instruction. Before that, I will explain one more thing. During the execution of the program, the microcontroller or microprocessor, the 3 steps of operation is done. First one is fetching. Second one is decoding. Third one is executing. What is the operation of fetching? It is fetching the instruction from memory. After fetching the instruction, it will be converted into code. That is called decoding. After converting the code, then executing, processing the data. That is called execution. So it has 3 steps of processes there: fetching, decoding, executing. The instruction register, it is used to hold the instructions. Then is sent to instruction decoder. It is converted into coding. This is one stage of operation is there. Next one, I already told, timing and important block, timing and control unit. It is generated timing, control unit and status signal. Control signals and status signals. What are the control signals? Ready. The processor is ready. Ready for the data transfer between two. Then next one, RD bar. RD bar is a read signal. WR bar, write the data to memory. Retrieve the data from memory. That is called read operation. ALE, that is address latch enable, that we will discuss later. The pin diagram details, it is clear, it is there. I will explain later. Then status signal, it has 3 signals. One is S1, S0, that is explained, that is only status signal S0 and S1. If the signal value is 0, 0, it is a fetching operation is doing. 0, 1, 1, 0, what is the operation? Next slide it is there, I will explain. Before that, IO bar, M bar, it is an important pin. So one is status signal. The processor in microprocessor, 8085 microprocessor, every time it will access with memory only. The same time, subsequently, lot of IO devices or IO external devices or peripheral devices, both are same only. Devices want to service with the microprocessor. So how it is interface with the processor? What is the function? It is want to service with the processor. How it is interface with the processor? If you want the service with the processor, it will generate the request. Any IO devices or external devices want to service with the processor, immediately it will generate the request signal. Once the request signal sent to processor, it will receive the processor. Automatically, the processor stop the current execution of the program. Immediately stop the current execution. Whether any interrupt will come means automatically stop. Then search it. Once the interrupt signal coming from external devices, immediately stop the current execution. Then provide the service to the particular interrupt. Before that, one acknowledgement signal send to processor. One request is coming from external devices. After receiving the external devices, the processor immediately send the acknowledgement signal to the particular device. That is, I already told, the processor always with the processor, memory. Sometimes it will access with IO device. How to identify? Through this pin only, IO bar, M bar. It is a very much important pin. If IO bar, M bar is equal to 1 means the processor is accessed with IO devices or external devices or peripheral devices. /M bar, it is active low signal. Active low signal means the 0 means it is active. So, if the input of the IO bar, M bar value is 0 means the processor access with memory. The IO bar, M bar is equal to 1 means the processor access with IO devices or external devices or peripheral devices. Okay, it is one of the status signal. Next signal is DMA. DMA means direct memory access. Without using processor, DMA is one of the IO controller. It is it is want to service with the processor. That means processor means not only the processor. It is used for only the processor, address bus and data bus. Before going to the topic, I will explain one thing. In microprocessor, how to communicate with the memory and IO devices through buses only. Buses means collections of groups of wires. In microprocessor, 8085 microprocessor has 2 types of buses. 3. One is address bus, one data bus, another one is control bus. The function of the address bus is, it is used to send the address, either memory address or IO devices address. Data bus, it is a data transfer between, I already told, the processor is connected with memory or IO. Between memory and processor or IO devices to processor, if you want to transfer the data through data bus only. In microprocessor has 8-bit data bus, that is D0 to D7. It is a bidirectional data bus because the data transfer from processor to memory or memory to processor or else IO to processor or processor to IO. Then third bus is a control bus. It is used to generate the control signals. Okay. Then if any one of the IO device, for example DMA, is want to service with the processor or the processor DMA controller want to service with by the address bus and data bus from processor. How to get it? By using the two signals. How to communicate DMA to processor? By using two signals. One is called hold, another one is called hold acknowledgement. If the DMA controller send the hold request signal to processor, what is the function of that hold request signal? They want need the service for address bus and data bus. It is requested to processor. For the purpose is data transfer. The processor, once the hold request signal generated from DMA to processor, once the signal is received, after receiving the signal, whether the address bus and data bus, microprocessor check the address bus and status, data bus status, whether the address bus and data bus is free means immediately send the acknowledgement signal to processor, controller, DMA controller. That means hold acknowledgement signal. These two signals are very important. One is hold request, another one is for hold acknowledgement. Another one, as usual, reset in and reset out signal. Then one more block is interrupt block. I already told the microprocessor access with IO devices or the external devices. How to communicate? It will generate the interrupt signal. Interrupt signal is mainly generated by any one of the IO devices. What is interrupt? It is used to disturb the processor. What is the purpose? It is if you want service with the processor, either data transfer or whatever. Okay, how? Interrupt has in microprocessor has 5 types of interrupt. One is called trap, another one is called RST 7.5, RST 6.5, RST 5.5, INTR. How to provide the service to interrupt? Once the interrupt signal generated any one of the IO devices, send it to processor. The processor receive the interrupt signal, immediately stop the current execution. Then processor send the acknowledgement signal. That is called INDA. The IO device generate the interrupt signal, that is called request signal, that is called INDR. Once the processor received, immediately send the INDA signal. How to provide the service? With priority. If at a time 5 interrupts signals, RST 7.5, 6.5, 5.5, INDR, those 5 interrupts at a time interrupted to processor. How to provide the service for all interrupts? Only the priority basis. How to provide the priority? Already programmed. What is the, I already told 5 interrupts. Trap is the highest priority interrupt. Subsequently, RST 7.5, 6.5, 5.5, final one is the INTR. Trap is the highest priority interrupt. INTR is the lowest priority interrupt. Okay. Then next one, serial IO control. Generally, 2 types of communication is there. One is called serial communication. Another one is called digital parallel communication. In serial communication, in 808 microprocessor has 2 types of serial communication there. 2 pins are there. One is called SID, another one is called SOD. SID means serial input data. It is used to input data serially into the processor. What is output? SOD. It is used to output data serially from the processor. That is a function of serial. It is used for only for serial communication. Okay. Address bus and data bus already clearly explained. These are all the block diagram blocks available in the architecture. Apart from these blocks, the 2 important registers are there. Initially, one is called accumulator and temporary register. We already discussed. Apart from that, another 2 registers. One is a general purpose register. General purpose register means It is a 8-bit register. In 8085 microprocessor has 6 general purpose registers are there. 6 general purpose, just you see it. 6 general purpose registers are there. Right side, the block diagram, it is right side, it is mentioned. B, C, D, E, H and L. All are 8-bit register. All are 8-bit register. If we want the service with 8-bit data, we can use this B, C, D, E, H and L. Suppose if we want 8-bit data, instead of 8-bit data, we want service with 16-bit data. Means how to communicate? It's a combination of 2 8-bit register. If we want to service with 16-bit data, you can combine 2 16-bit data. How it will combine? B and C. Finally, we will get BC register pair. B is one of the 8-bit register. C is another one of the 8-bit register. Both are combined. We will get BC register pair. The same thing happened in the D and E register. Both are 8-bit register. If we want to combine with the D and E register, finally we will get DE register pair. We can transfer 16-bit data through DE register pair. Okay, are you understand now? Okay, next HL register. H is one of the 8-bit register and L is another one of the 8-bit register. If we want to service with the 16-bit data, we can combine both H and L register. Finally, we will get HL register pair. The HL register pair, another one name is memory pointer. It is used to hold 16-bit data. The next important point is 8-bit registers are almost over. We explained all the registers. Then next goes to 16-bit register. 2 16-bit registers are there. One is called program counter. Before starting the execution, the starting memory address is always placed in the program counter. It is a 16-bit register. It is used to hold 16-bit memory address, which the memory address is the next to be executed of the instruction. Program counter. Every line executed during the execution of the program, every line is executed, the program counter value is incremented by 1. Then next one is stack pointer. Stack pointer, I already told the RAM memory is a random access memory, always called a data memory. So one part of the RAM memory particularly assigned the particular area in the inside the RAM memory, that is called stack. One part of the data area placed assigned in the RAM memory, that is called stack. What is stack pointer? It is also 16-bit register. The topmost part of the stack is called stack pointer. Okay, it is a 16-bit register. How to activate stack pointer? How to access the stack pointer? By using 2 instructions. If you want to store the data to stack, by using push instruction. After complete the push instruction, the stack pointer value is automatically decremented by 1 in microprocessor 8085. Then next one, how to retrieve the data from the stack? So one more instruction is there, that is called the pop instruction. By using the pop instruction, we can retrieve the data from the stack. One more thing, during the retrieving the data by using the pop instruction, after complete the pop instruction execution, the stack pointer is incremented by 1. Stack pointer is incremented. This is a function of registers, 8-bit register and okay. Then we will see pin details of 8085 microprocessor. I already told 8085 microprocessor is a 8-bit processor. It has 40 pin IC. In the IC format, it has 40 pin IC. Number of ICs 40s. It requires plus 5 volt power supply. Then it requires the 3 frequency. But here 40 pins are there. We will explain one by one pin. The pin of 8085 can be classified as given below. What are the parts in the pins. It has totally 7 parts, important, power supply and frequency signal. Under the power supply and frequency signal, power supply means positive and ground, plus 5 volt required power supply and also ground is there. Frequency signal, crystal 1 and crystal 2. Then address signal means already I told it has 16-bit address bus is there. It is used to store the 16-bit of memory address. It is used to send. What is the use of address bus? It is used to send 16-bit memory address. That represents A0 to A15. For the programming purpose, the A0 to A15 address bus is divided into 2 parts. It is a unidirectional address bus. It is a 2-part. One is called lower order address bus, another one is called higher order address bus. For the programming purpose, already, next one, data bus. Data signal sent to data bus. Data bus represents D0 to D7. For the programming purpose, it is combined lower order, multiplexed, data bus and address bus. Finally, we get AD0 to AD7, AA to A15. Initial lower order multiplexed address data bus with pure AA to A15 address bus is there. Okay, control and status signal. Already we explained what are the control signal. Ready, read, write, ALE. Status signal S0, S1. Okay, IO bar, M bar. Then interrupt. We have 5 interrupts, namely trap, RST 6.5, 7.5, 6.5, 5.5, INTR. At a time, the 5 interrupted to the processor immediately provides the service with the priority basis. Based on the priority, trap is the highest priority interrupt, INTR is the lowest priority interrupt. Then to a serial operation is there. Serial devices, if you want to connect to the serial device through the serial IO signals, it has important 2 signals. One is called SID, another one is called SOD. So many acknowledgement signals for cold hold acknowledgement. These are all the acknowledgement signal through this pin. Read operation, write operation, ready, data bus, ALE, RD bar, WR bar, IO bar, M bar, S1 and S0 is a status signal. Here S1 and S0 values. This is a status signal. 0 value 0, 0, it is a halt state. Halt means end state. Then the value change 0 to 1. The processor is doing write operation. 1, 0 means read operation. 1, 1 means fetch the instruction from the memory. Fetch operation. External initiated and interrupt signals already explained. RST, reset in, reset out, ready, hold acknowledgement, INTR and INTA. INTR is an interrupt request signal, INTA is an interrupt acknowledgement signal. RST 6.7.5, 6.5, 5.5 trap is a highest priority interrupt, SID, SOD. These are all the signals. Okay, thank you. Remaining classes will continue next class. Okay, remaining portions I will continue next class. Okay, thank you.